Hey everyone, welcome back to Mastering Full Stack Development. I'm excited to have you here again. Today, we are going to talk about rate limiting. This is an important concept for managing traffic to your API or service. So, what is rate limiting? It's a way of controlling how many requests a user can make to your API in a given time, like allowing only 10 requests per minute. And why is this important? Well, without rate limiting, users get overload your server with too many requests, slowing things down, or even crashing your app. Rate limiting helps in protecting your system from abuse. Alright, let's dive in and see how we can add rate limiting to our app. Let's create a new folder in our common project, policies. Let's name it as rate limiter policy. Let's add a class rate limiter policy definitions. This is where we will define the policies for our rate limiter. All right, let's create it. Okay. Let's make it public, static. Let's add our fixed window limiter policy. All right. This will take the options of fixed window limiter. Let's define this. All right. Let's add another policy as partition policy maybe. All right, this will return a function that takes an HTTP context and returns a rate limiting partition string. All right. Let's name it as fixed window limiter partition policy. Let's configure it. Right now, we don't have any partition policy based on user or anything, but for the sake of foundation and for the sake of demonstration, I'm adding this policy as well. All right. This will return a function. Let's take the partition provider key as parameter as well. All right. Now, this will return a function that takes the context and return the rate limit partition key. All right, let's define the option for that. We have the partition key. which we will get in the parameter. Alright, maybe I can just fix this. We can maybe create an options class to define the options. Let's complete this first and then let's refactor it to define the options. You'll see the difference when we'll define the options. So our customization can really be enhanced with those options then. All right. So we have configured the partition key and the factory. And now let's maybe create an option class. All right. Let's call it as rate limiter options. We'll add all the options for different policies in here. So let's add our fixed window policy options first. We can add a couple of properties in it, the permit limit and the window property. Let's set our permit limit to say 10 requests by default. And let's set our time span of window to say something like 1 minute. This is the default time, default values for those things. All right. Next, let's create a partition policy options as well. Let's complete this first. Now let's create a partition policy options as well. We can inherit it from the fixed window policy options since we require those two values. So we will define our partition key provider in this class to make sure that we have a value against it. Let's add a public property and let's define them. Let's create a private variable and let's define the public property. We can just add the getter and setter to validate in the setter that we have a value against, we have some value for it. And if not, we can throw some exception. All right. Let's define the public property for it. Let's add our getter. And let's say when we are setting up the value, if it's not there, let's throw an argument null exception here. With these option classes defined, we can now use them in our policy definitions to manage rate limiting effectively. All right. Now let's integrate our options into our definitions. This will allow us to use the configurations options we just created for setting up the fixed window rate limiter. These changes ensures a flexible and configurable setup. We can do a lot of customization with it later using the I options. Let's do the same for the partition part. All right, you see, This looks much more cleaner now. All right. Let's add our enum folders. Let's create a class with named constants. And let's define our rate limiter policy enum. This way, we will have a clean and consistent way to refer to our rate limiting policies throughout our code. Let's define the enum and let's add our policy definitions. We can add more policies in our code and we can just add them into enum and can refer them later anywhere throughout our code. All right. This looks so much clean now. All right. With this done, let's create our rate limiter service extension. Let's create a class, rate limiter service extension. Now this class will help us register our rate limiter services dynamically, as we did with the course thing as well. So throughout our microservices, our API gateway, we can use these common libraries, common things we are making up. So we are building some strong foundation. These would be really helpful in other microservices we are going to build later down the line. All right, let's add our custom fixed window rate limiter method. Let's name it like this. This will take 2 arguments, the policy name and the options. And obviously it will return the services configured. Let's take our options as well. Okay. Now first, return the services. With this, let's check first if the options are null, since we need those options along the line. So let's add the rate limiter services, and with these options, let's first check if the options we are receiving in our parameters should not be null, and if they are null, we can throw some exception. We can throw an argument null exception. All right, what if our requests are rejected? So we need to cover that case as well. Let's throw an exception in that case as well. All right, so if our options are rejected, we are going to throw an exception in that case as well. Let's define the context and cancellation token later. I am thinking to create our own exception, a custom exception. This way you will learn how to create a custom exception. All right, let's create a custom exception. In the exception folder, Let's add a rate limit exceeded exception class. Let's create this class. Alright, this class will be inherited from the base exception class. So with this, we can have our own exceptions configured. Alright, we won't be doing much in here. Let's just define the constructor which takes a message. And that's it. Let's do this. Alright, back in our code. Let's head back to our method. And now we'll throw the rate limit exceeded exception when a rate limit is exceeded. You see, we created our own exception class. Let's type in something. Let's say rate limit exceeded. Something like rate limit exceeded, try again later. Alright, maybe we need to add the context and cancellation first. Let's add rate limit exceeded. And also add the context and the cancellation. Alright. With that, let's proceed with defining our cases. Let's start with fixed window policy. So we have definitions. We have two of them. Let's start with fixed window policy, which will be followed by a partition window policy, and for the default case we will throw an exception. Alright, for the case of definitions we have fixed window policy definition. Okay, let's define it later. Let's add just our cases first. We have fixed window policy, and then we have partition window policy. Let's copy it, let's paste it, and let's say partitioned window policy. Alright, let's define our default case as well. And usually we do throw an invalid operation exception. So we don't have a policy defined. So say unknown policy, and let's return the policy name as well. Alright, now let's define our cases. This is going to be a very straightforward case, but we are going to play around with the partition policy case. I'm thinking to add block users list as well, so that we can have a list of block users, and with the partition policy we can throw an exception whenever we catch such user or such IP. We just throw an exception of unauthorized. Let's do that too with our partition policy. All right, let's define our options. All right, now first let's check if the options are type of partition policy. Since we need the provider key, so let's ensure that we are getting the partition policy options for the case of partition policy. If not, we will throw an argument exception. All right. So let's say we define and we need those partition policy key. Those are required. Now let's configure our policy now. Add policy. And let's just fetch the partition key from the context first. So we have our context. Let's get the partition key. Let's also define a list of blocked users, and we will check if partition key matches any user in the block list. If it does, then let's throw an unauthorized exception. Let's do that too. This way you'll learn how you can block list some users or some IPs that are doing some malicious stuff on your application. So you can monitor them, you can observe those IPs, and you can just put them on the blocked list or the blacklist. All right. Let's do that too then. Let's define a list of blocked users. Let's say, for instance, we can add some IP in here. All right. Now before proceeding, let's add a check that if the partition key we received from the context contains any of our blocked user list. If it does, let's throw an unauthorized access exception. Let's say access denied. All right. Let's proceed to configure the partition window policy. And I believe we are pretty much done then. We'll have to configure our gateway. All right. This looks good. All right, let's move on to our routes. And let's add our rate limiter policy. For now, let's define the fixed window policy for our weather API. And I'll make sure that we'll test both the policies and all the cases that we can. I have 3-4 cases in my mind. Let's first test the fixed window, And let's test the partition window as well with providing the IP of a blocked user, and then we can provide IP or user ID even from the context. That's what we usually do. Alright, so we missed our custom exception handler class, so I'm adding it in here as well. And now let's define our custom rate limiter policy. Let's register both of our policies. But the one that is configured in the route of the microservice will be used. So for now, let's define both of them and we'll test both of them one by one. Usually it's the highest number for a minute, let's say 100 requests per minute. For now, for the sake of testing, we are defining just one. So you can just call once per minute. Let's copy it and define our partition policy as well. Now let's define our partition provider key. Let's first define the same IP we hard-coded there so that we get the access denied exception when we are testing the partition policy case. .1.1. Let's return this user. And let's also get the user ID from the context. Alright, let's say if the user ID is not null, return the user ID, else return the IP. So we are configuring it both now. Since we don't have any context.user for now, we'll add our identity service later down the line. So we'll have our context.user in there. Then we'll use the partitioned policy. For now, let's just test it. All right. Let's just comment this out for now. Oops, we need that IP. And seems like my compiler is going crazy. All right. Okay. All right, let's test it. Let's open our Postman. So we have our API gateway up. Let's test it. All right, so we get an error. Okay, so what's it about? So it's routing to 3012. All right, we have enabled those things for our load balancing, but this server is not running. Let's comment those servers out. We have only 3011 running for now. Let's comment it out. Let's comment them and let's move on. Let's try again. All right. So we have allowed one request per minute, which means that we will have one successful request, and then it will fail if we try again within a minute. All right, let's see. So we have a success. Let's try again. And here you go. It throws an error. Rate limit exception error. All right, we see 500 in here. Okay, maybe we didn't define our custom exception in our custom exception handler. All right, let's do that then. Let's define our custom exception in our custom exception handler. For the rate limit exception, let's return 429 status code, indicating that the rate limit has been exceeded. Let's do that now. Let's copy it and paste it out. All right, let's say 429. So my compiler has been acting all weird. All right, that's done. Now let's test it again. And there you have it. A 429 too many requests. Sorry for the language. And now let's switch to the fixed window partition. Let's test that policy out as well. So, as expected, we get the access denied. So it didn't even allow our one request to go through since we added that IP in our blocked users. And we get the access denied error. Now let's switch our cases again. Let's now take some IP from the context. It will search for user first, but since we don't have any users right now, it should provide us with IP from the context. If our code does what it says, let's try it. All right. So this time it should work for the first time. You see, you have my IP there. This should work now. And now it should work and say an error. This should be a rate limit exceeder since we only allowed one request per limit. All right. So we are done with this. Let's do a recap. So in this video, we created a rate limiter policy definitions with fixed and partitioned window policies. We also set up fixed and partition window options for customization. Then we implemented the rate limiter service extension to dynamically register services based on policy. Then we created our custom rate limit exceeded exception for handling exceeded limit exceptions. And then we finally added policies to routes and tested both fixed and partition window policies. All right. If you found this helpful, give it a thumbs up. And also don't forget to follow, share, and subscribe for more insightful content. Your feedback and support keep me motivated to bring you even more valuable tips and tutorials. See you in the next video.